In this video, we will be talking about derivatives. We shall start off with the basics. So basically, the derivative of any number that's a constant or any real integer, say, let's consider 7, it's going to be 0. Likewise, for the derivative of something like 1000 would be 0. The derivative of -6 would be 0. Any integer, it would be 0. The derivative of 3.5 would be 0, and so on. Now when we start off with derivatives with exponent, like derivatives somewhat like let's say d over dx, that's the derivative of x to the power of n, where x is any integer and n, as obvious as it looks, is its exponent or its index. So n is the exponent, x is the normal constant. We bring this number to the front, we multiply it by x and we subtract 1. So this is basically equivalent to nx to the power of n minus 1. Likewise, if we consider the derivative of, say, x to the power of 5, the answer would be 5x to the power of 4, because what we did was we brought 5 to this side. 5 times x is equivalent to 5x, and we subtracted 1. So this is equivalent to 5x to the power of 5 minus 1, which is equivalent to 5x to the power of 4. Likewise, a question like x to the power of 4 would be, we would be bringing 4 over here and subtract 1. That's 4x to the power of 3. Since we know the basics of derivatives, we shall try solve this. The derivative of 4x to the power of 5. So basically, what we do over here is we take the 5 in front and we multiply it by what's inside. It has its exponent, that's 5 minus 1. That's then equal to 20x. No, actually not like that. That's a wrong algebraic representation of it. To the power of 5. We multiply it by what's inside. We get 20x to the power of 5 minus 1, which is equivalent to 20x to the power of 4, thus being our answer. So with the same technique and the same logic, we shall try solve, let's say, the derivative, sorry, wrong color, the derivative of 5x to the power of 3. The same way we bring 3 in front, thus becoming 3 times 5x to the power of 3 minus 1, giving you 15x to the power of 2. Alright, so now with that logic, let's say we have a question like this. This is a polynomial. So let's say it's okay. No, let's start it like this. The f of x is equivalent to 6x squared plus 3x cubed plus 5x minus 2. Alright, and then they tell us to find the derivative of f of x, or basically f prime of x. what you do in this is merely it's merely the same as what we did for the others. We use the same logic. So let me add a bracket over here. It's not the same color, so let me just add the same color. Color is important, like so. Okay, so we first start off by taking the derivative of each and every term in this example. So the derivative of 6x squared is equivalent, we take 6x, we take the exponent to this side, we get 12x to the power of 1 because we subtracted 1 from it, right? And then with the same logic, the derivative of 3x cubed, that's equivalent to 9x squared. The derivative of 5x, so it's 5x, it has an exponent of 1, we take it to the other side and we subtract 1. That's 5 times x to the power of 0. Anything to the power of 0 is 1, and so that's 5 times 1, which is equivalent to 5. And again, the derivative of any constant is just 0, which is finally equivalent to 0. We can rewrite this. Let me just make it more neater. We can rewrite this by just a second. Alright, basically we can rewrite this whole formula, or not formula actually, expression, as the terms we first got. The derivative of 6x squared is 12x. Let me just rewrite the derivative over here. The derivative of 6x squared is equivalent to 12x, and the derivative of 3x cubed is equivalent to 9x squared. So 12x plus 9x squared plus 5 minus 0. That's just 12x plus 9x squared plus 5. That's our answer. So the answer is equivalent to 12x plus 9x squared plus 5. And there it is. Yes. And that's it. So we can move on to so after this we can move on to, say, rational derivatives. Alright, so let's say we have to get the derivative of 1 over x squared. What we will do is we basically have to rewrite it. So 1 over x squared is equivalent to x to the power of negative 2, because when we flip 1 over x squared, when we take it reciprocal, the exponent becomes negative. Just like the way we have anything to the power of a negative, we get it as 1 over x to the power of b. Likewise, if we have x to the power of negative 2, it's equivalent to 1 over x to the power of 2, just as what was represented over there. So basically, as we know, again, 1 over x squared is equivalent to x to the power of 2, because we take it up, the exponent becomes negative. And then we get the derivative of x to the power of negative 2, because all we have done is we just rewrote it. It was just rewritten. So this is equivalent to negative 2x to the power of negative 3, because we got the exponent to this side, that's negative 2 minus 1. Negative 2 minus 1 gives you negative 3, and so negative 2x to the power of negative 3 shall be your derivative for this. we should rewrite this to get rid of the negative exponent, and we get negative 2 over x to the power of 3. Whenever we take the sign would always change. So example, if I would have 2x to the power of 3, I take its reciprocal, I would get 2x to the power of negative 3. But we don't want the negative exponent, so we put it back and we get 2x to the power of 3. And so the answer for this sum or derivative would be negative 2 over x to the power of 3. Alright, so let us consider this. Let's say we have, with the same logic, this is merely the same as what was there before. 1 over x a to the power of 9. Now 1 over x to the power of 9 is equivalent to x to the power of negative 9, because when we flip it, the exponent becomes negative. And then we take the derivative of x to the power of negative 9, because we just rewrote it. We did not take the derivative of it. This is equivalent to negative 9x to the power of negative 10. We took this to this side and we subtracted 1 from it. So basically, it's negative 9x to the power of negative 10. To get rid of this, we rewrite it negative 9 over x to the power of 10. We do not want this negative exponent, and so that remains as your final answer. Final answer is negative 9. Oh lord, not that. Negative 9x to the power of 10, not 10 to the power of x. And yes, that is how you go about rational derivatives. But we are not yet done. Let's also consider the derivative of 8 over x to the power of 6. You guys can feel free and work it out yourself, and then unpause the video and get the answer. So 8 over x to the power of 6 is equivalent to 8x to the power of negative 6. We flipped it, and x to the power of negative 6 is a coefficient of 8 over 1. Since we only rewrote it, we take the derivative of 8x to the power of negative 6. We take the 6 to the other side and we get negative 48x to the power of 7. This is because we subtracted 1 of it from it, so that's negative 48x to the power of negative 7. Alright, so we got this. Now we rewrite it because we do not want this negative exponent. We want to simplify it. So we rewrite it and get negative 48 over x to the power of positive 7. And so your answer, okay wait, when I underline the positive, it seems as though I'm saying plus or minus, so I'll remove that. Okay, fine, that's our final answer. So basically, the derivative of 8 over x to the power of negative 6 is equivalent to negative 48 over x to the power of 7. That's how you go about it. When we come to talk about the radical functions, basically, by what I mean by radical is if I have an expression like the square root of x, it can be written as a square root. It can be written as x to the power of 1 over 2. This is because x has an exponent of 1 over here, and we are taking the square root of it, and so it becomes like this. Say I have x to the power of b over here, and that's x. No, sorry, not x. And that's say m. I can rewrite this as x to the power of b over m. B is the denominator, m is the b is the numerator, m is the denominator. So with that logic, let's consider the sum the derivative of, say, the derivative of the square root of x to the power of, say, y. So as we discussed, this becomes the square root of x to the power of y becomes x to the power of, the square root of x to the power of y, yes, becomes x to the power of y over 2. And since we only rewrote it, we take the derivative. Excuse me. That's the derivative of x to the power of y over 2. Now that becomes y over 2x to the power of y over 2 minus 1. 1 can be written as 2 over 2. So that's y over 2 minus 2 over 2, which is equivalent to y minus 2 over 2. And yes, that is your answer. So the derivative of the square root of x to the power of y is equivalent to y minus 2 over 2. So let's consider the expression. Okay, basically let's just take the derivative of the square root of x. Okay, that is a very horrid x. Apologies. Yes, no, that x is not horrid. So the square root of x is equivalent to x to the power of 1 over 2, and so we take the derivative of x to the power of 1 over 2. When we take the derivative of x to the power of 1 over 2, we get 1 over 2x to the power of 1 over 2 minus 1. 1 over 2 minus 1 is the same as 1 over 2 minus 2 over 2. Hence, the answer negative 1 over 2. This is equivalent to 1 over 2x. Sorry, this is a bit too slanted. This becomes 1 over 2x to the power of negative 1 over 2. This can be rewritten to get rid of the negative exponent as, okay, first of all, this becomes x minus, or let's just keep 1 as the coefficient over there, also as the coefficient of x, 1x minus 1 over 2, 1x to the power of negative 1x to the power of negative 1 over 2 over 2. We bring the x to the power of negative 1 over 2 down, and so we get x over 2x, not x. We get 1 over 2x to the power of 1 over 2. X to the power of 1 over 2 is equivalent to the square root of x, and so the final answer is, let me just delete this, and okay, so the final answer is 1 over 2 times the square root of x. So the derivative of the square root of x is, oh lord, my handwriting is devious. Okay. Is equivalent to 1 over 2 times the square root of x. Alright, that's it. And with that said, let's try do this. Let me change the color. And so the derivative of the 8th root of x to the power of 3. So what we will do here is merely the same as what we did as the square root of x. So 8, oh lord, the 8th root of x to the power of 3, it's equivalent to x to the power of 3 over 8. And with this in mind, we shall take the derivative, or the derivative, not the derivative, the derivative of x to the power of 3 over 8. That's equivalent to 3 over 8x to the power of 3 over 8 minus 1. 3 over 8 minus 1 is the same as 3 over 8 minus 8 over 8, which is equivalent to negative 5 over 8. So that's 3 over 8x to the power of negative 5 over 8. And that can be written as, 3x to the power of negative 5 over 8 over 8. We bring the x down, and so we get, to get rid of the negative exponent, and so we get 8x to the power of 5 over 8. So the derivative of the 8th root of x is equivalent to 3 over 8x to the power of 5 over 8. Yes, that's how you go about radical functions, or the derivative of radical functions. And now we come to the derivative of trigonometric functions. In trigonometric functions, there is a specific set of rules and a specific set of formula that you have to follow in order to obtain your answer. So basically, you need to know, not memorize, because in most of the SATs, I believe in the SATs, you're given a formula sheet, but the formula sheet is not helpful, really. It's only helpful for some terms, and since you have limited time in the SAT, it will be very tedious to just keep on flipping the paper up and down and try get the formula for it. So basically, the best thing to do is to remember them. So the derivative of sine of x is equivalent to cosine of x times x prime. The derivative of cosine of x, and note that anything that starts with a c it's negative. That's negative sine of x times x prime. Okay, wait, let's use a different letter actually. A different letter would be way better, because the multiplication sign and x looks quite it looks very weird. Not weird, it looks cool, but together would look confusing, because math is cool, so nothing in math is weird. Alright, so let's use u as per the book I'm using. So this is equivalent to cosine u times u prime. This is equivalent to negative sine u, or negative sine of u times u prime. The derivative of cotangent, or let me start with tangent actually. Tangent u is equivalent to secant squared. It is equivalent to secant squared of u times u prime. The derivative, oh, it seems as though I don't have any more space, but it's okay. The derivative of cotangent actually. Cotangent u is equivalent to negative cosecant squared of u times u prime. The derivative of secant u is equivalent to secant of u times tangent of u times u prime. And if you guys are jotting this down, I will just write it here, this side, if that's neat. The derivative of, okay, you know what, let's just not consider that. We shall write it on top over here. I should have considered writing in a way smaller handwriting. Alright, so the derivative of the last one, that's I believe, yeah, cosecant of u is equivalent to cosecant of u times cotangent of u times u prime. Now with this in mind, let's start off with the sums. So let's say we have to take the derivative of cosine. The derivative of cosine of x. Now we know that the formula is basically equivalent to negative sine of u times u prime. Now with this in mind, we know that u is equivalent to x and u prime is equivalent to 1, because the derivative of x is, you bring the 1 to the other side, and 1 minus 1 gives you 0, which is x to the power of 0, which is just 1. We can plug into the formula and times 1. So your answer is basically negative sine of x. Alright, so with that in mind, let's try sine now. I should have just done it together. Or never mind. Actually, that would be very illogical. Alrighty. So, okay, okay, never mind. So anyways, this, let's say it's sine of x. So basically we know the derivative of the sine of x is, or let's say the derivative of any sine u is equivalent to cosine of u times u prime. Okay, that was a really big apostrophe. Okay, so u in this case is again equivalent to x. U prime is equivalent to the derivative of x, which, as we saw in the last example, was 1. And so we plug into the formulas and we get the cosine of x, because u is equivalent to x, times 1, and your final, okay, that looks like an e, sorry. And that's just cosine of x as your final answer. That's just the cosine of x. So let us try, say, the derivative of cosine of x squared. Alright, so now we know the derivative of cosine of u is equivalent to negative, oh yeah, wait, u is the square bracket is more suitable, is equivalent to negative sine of u times u prime. And in this case, u is equivalent to x squared, and u prime is equivalent to 2x, because we brought the 2 to the other side, and u prime is basically the derivative of this, of x squared. So we plug into the formula, we get negative sine of x squared, negative sine of x squared for u is equivalent to x squared times u prime, that's 2x. We can consider bringing this to the other side, and our final answer shall be 2x times the negative sine of x squared. That is our final answer. Right. With the same logic in mind, let us consider the derivative of sine x cubed. Sine x cubed. Now the derivative of any sine of u is equivalent to cosine of u times u prime. So u is equivalent to x cubed, u prime is equivalent to 3x squared, and so this is equivalent to the cosine of x cubed times 3x squared, which is just 3x squared cosine x cubed. That's just 3x squared times cosine x cubed as our final answer. So let's consider tangent. Let's use the tangent function now. Tangent of this time, let's say x to the power of 6. Alright, so we are aware that the formula for tangent of any u is equivalent to secant squared of u times u prime, and in this case u is equivalent to x to the power of 6. It would only be logical if u prime is equivalent to 6x to the power of 5. So we plug in x squared for u and 6x to the power of 5 for u prime. That's secant squared of x to the power of 6 times 6x to the power of 5. That's 6x to the power of 5 times secant squared of x to the power of 6, or times x to the power of 6. So that's equivalent to 6x to the power of 5 times secant squared times x to the power of 6. Alright, now let us consider the question. Let's try the derivative of secant of 4x, or just the derivative of secant of 4. Yeah, basically the same thing. That's the derivative, the derivative of secant of 4x. Okay, no, now this doesn't look good. No, not that C. 4x is equivalent. So we know that the derivative of any secant u is equivalent to is just equivalent to secant of u times the tangent of u and times u prime, where in this case u is equivalent to 4x and u prime is just equivalent to 4, as we saw in the previous examples. So with this in mind, we can plug into the formula. The secant of 4x times tangent of 4x again times u prime, that is 4. We can take 4 to the other side and get 4 secant 4x tangent 4x as our final answer. That's 4 times secant times 4x times tangent 4x. That is our final answer. And for the last question, let us make it a bit more trickier, which is way more fun because math is elegant. And so is science. So let us consider the derivative of cotangent of x plus x to the power of 3 plus x to the power of 5. So we know the derivative of cotangent of any u is equivalent to negative cosecant. Sorry, not negative, that's the one for cosecant. It's equivalent, actually yes, it's equivalent to negative cosecant squared times u, or negative cosecant of u times u prime. So we know that u is equivalent to x to the power of 3 plus x to the power of 5, and u prime is equivalent to 3x squared plus 5x to the power of 4. We just took the derivative of each term, which is equivalent to 3 squared, and that's equivalent to 5x to the power of 4. So basically, we can plug into the formula cosecant squared of x cubed plus x to the power of 5 times 3x cubed plus 5x to the power of 4, which can be written as cosecant squared to the power, or cosecant squared times x to the power of 3 times plus x to the power of 5, and we can keep this in brackets, x to the power of 4. We should take that to the other side. That's 3x squared plus 5x to the power of 4 times negative cosecant squared times x cubed plus x to the power of 5 being our final answer. It's 3x squared plus 5x to the power of 4 times negative cosecant times squared, actually, times x cubed plus x to the power of 5. And that is your final answer and the last practice question for today. Bye.